So the next concept that we will start is foreign key concept, right? So what exactly is a foreign key, right? So till now we have been using single tables for all our examples, right? Now at some point what we have to do is create multiple tables in order to store the data, right? So say for example, I have a customers table, right, which has customer ID, customer name, and contacts. Right now, I want to have a orders table in which I want to store which customer ID ordered on which date. Right. So if you see here, I have this is the order ID, right, which is a primary key for the orders table. After that, I have a customer ID and order date, right? So this customer ID is nothing but the customer ID from the customers table, right? This is what it represents. That means this customer ID on customer table is the primary key, and that column, when it is referenced in another table, that is called as a foreign key. So this customer ID in orders table is a foreign key to the customers table's customer ID column, right? So this creates a relationship between these two tables. That means this customer ID on orders table references customer ID from the customers table, right? On customers table, this customer ID is the primary key, and on the orders table, this customer ID is the foreign key, right? That is the whole concept of a foreign key, right? So we'll take some example and we'll see. Right, so here we have a department table, right, which has a department ID and a department name, right? So I'll create the table first. Okay, a table is created. Now in employees table, if you see, I have employee ID, employee name, and I have this department ID, which refers to this department ID in departments table. That means this employee belongs to which department is stored as department ID in this table in employees table, and this department ID refers to department ID in departments table, right? Now how I have established foreign key relationship? I'm saying foreign key is department ID. This department ID is this department ID in the employees table, right? So foreign key is department ID, which references departments table department ID, right? So this department ID is this department ID, right? And this department ID belongs to this table department ID, employees table department ID. So foreign key department ID references which table? Departments table department ID, right? An important thing is the two data type should match, right? We cannot have a varchar here and an integer here to create a reference or a foreign key reference, right? Now if I run this one, I'll be able to create the table, right? Now we will insert some data into the table, right? So here I am inserting some data into the departments table, right? ID1, then department name, ID2, department name, ID3, and department name, right? So I'll execute this one. Then on employees table, what I'm doing, this is employee ID, employee name. This is the department ID which refers to this department ID. That means this user ID1, or sorry, employee ID1, Alice, belongs to department 1, that is HR department. Similarly, if you see Charlie, the ID is 3, department ID is 3. That means this 3 belongs to this IT department, right? So if I execute this one, I'll be able to execute this, right? Now if I do select star from employees, right, I'll get employee ID, employee name, department ID, right, and its salary. So this department ID is nothing but a foreign key to the departments table department ID, right? Now the obvious question comes is, why do we need this foreign key reference, right? Even without reference, I should be able to, or I will be able to enter this 1 and this 2 and this 3 and this 1 and this 2 in the employees table, right? This will not stop me from entering, right? But then what is the whole idea of having a foreign key, right? As such, it won't stop me from entering data, right? So I'll be able to enter data freely, right? I should be able to enter anything in this column, right? It may refer to another table, it may not refer to another table, but I should be able to independently enter the data, right? So why do I need to have a foreign key here, right? Now, to show you why we need a foreign key, I will try to insert an employee with a ID, with a department ID that doesn't exist here, right? So if you see what I'm doing, insert into employees, employee ID is 6, from here it is 5, so I have added 6, employee name, right? Now department ID is 4, I'm trying to enter, and some salary. But if you see, we don't have a department ID 4 here in our department table, right? What will happen if I try to insert this one, right? Now, before I tell you what happens, now just imagine if somebody is trying to take out a report in which what he is trying to do is he's trying to find all employees and their department, right? If we don't have a foreign key relation, we will be able to insert this data, but the moment in which we try to find the department of employee ID 6, we will get null, right? Which is not desirable, right? This is kind of a corrupt data. We don't want to have employees without a department, right? So this way our data will be corrupt. So if I am able to insert this, then that is wrong. That destroys the integrity of the database, right? So if I try to execute this one, right, of course it will throw error, right? Because this employee ID, sorry, this department ID 4 doesn't exist. That's why I have to have a strong foreign relationship so that it will prevent this kind of error data entry, right? This is what is called as referential integrity. That means if my table points to another table's key, I should not be able to insert a data that doesn't exist on the parent table, right? Otherwise I'll end up in corrupt data, right? Which is not the state I want my database to be in, right? So if I have a strong foreign key relationship, this kind of error will be quickly prevented, right? So that's why we need a foreign key relationship. Otherwise, I will be able to enter the data even if say for example 4 is not available in the departments table, right? But the question comes on the data integrity, right? I will be able to enter haphazard data into the database, right? So I need a strong relationship between database. That's why it's called relational database, right? That's when the concept of RDBMS comes into picture, right? So that's how I create relationship, and that's how I prevent data from losing its integrity, right? Okay, now we will take this scenario, right? What I'm trying to do is delete department ID 1, right? Now, department ID 1 is human resources. I want to delete the department, right? The problem is in my employees table, there is at least one row which refers to department ID 1. If I delete the department ID 1, again my data will be in corrupt state, right? Because when I try to run a report on Alice or David, which department they belong to, I'll get null data, right? Which is not what I want, right? So now if I try to delete it, it will throw error saying that cannot update or delete a parent row. Why? Because this row is referred in employees table, right? That's why I created a foreign key relationship. This will not allow me to delete a parent row if the department ID or the column is used in another table, right? Now what is the solution for this one? Of course, the first solution is I'll go manually into the employees table, right, and delete all employee ID or employee ID in which the department ID is one. That is one way. But there is a possibility that this department ID may be a parent to maybe 10 or 15 number of tables, right? This is just a dummy tutorial scenario. That's why we have only 2 tables. But in real life, you might have 10 or 20 tables of which there is a single parent. Possible, absolutely possible, right? In that scenario, you cannot go into each and every table, delete the child and delete the child from each table and then come to parent table and then try to delete. Not possible, right? So for that, what we do is there is a statement called on delete cascade. right? We will see how it is used. So for that, what I will do, I'll delete the employees table, right? And we'll recreate it with the new condition, right? I'll keep the departments table as it is, right? Now, so what I'll do, I'll try to recreate the employees table. But now if you see, everything is same. Here also I'm doing foreign key referencing to department ID from departments table. And here what I'm doing is on delete cascade. That means if the primary key is deleted, or if the key on the parent is deleted, delete the child row as well. That's what this means, right? That means if I try to delete a department ID 1 from the departments table, on the employees table as well, all the rows that have department ID 1 will also be deleted, right? So I'll execute this, right? After this, I'll try to insert the data, right? I'm able to insert, right? Now, if I do select star from employees, right? So we have one person called Alice with department ID 1 and one person called David with department ID 1, right? Now what I will do is I'll try to delete department ID 1, right? Right now in employees table, I have two rows which points to department ID 1, right? So I'll delete this one. This time delete succeeded, right? Delete succeeded because this time it also deleted the rows from employees table as well, right? Now if you see, we don't have employee ID 1 anymore, we have 2, 3 and 2, right? So that's what this statement does on cascade delete. That means if the parent department ID is deleted, delete this row as well. That's what on cascade delete means, right? Now we'll drop the employees table again and we'll look into the next concept, right? Okay, this was about deleting the parent key, right? Now what if I want to update the parent key, right? What if I want to update the parent key? That means I'll delete the department table also. We will again start from scratch, okay? Right, so if you see here, departments table, same as department ID and department name, right? Here employee ID, name, department ID. This department ID is a foreign key to the department's department ID, right? And here if you see, it says on update cascade. That means if the parent ID or the parent's department ID is updated, update the child department ID also, right? So we'll check the example. We'll execute this one, we will execute this one, right? And what we will do, we'll insert few statements, right? So department value, what I'm entering, 1 HR, right? Then I'll insert 2 more into the employees table, right? So ID, name and department ID, right? Both of them points to department ID 1, right? Now I'll say select star from employees, right? So here department ID is 1, right? Very simple till now. Now instead of deleting, what I'm doing is I'll update. Okay, what I'm doing here, update department ID, update departments, set department ID equals to 2, where department ID equals to 1. That means this department ID 1 HR, I am changing it to 2 HR, right? So I will, and before that, let me show you select star from departments, right? We'll see. So we have 1 HR, right? What I will do is I will update. I'll run the update statement, right? It updated. I'll see the department table. Here, if you see, this has become 2, right? But in our employees table, we have this 1 and 1 as the key, right? Now, because of the on update cascade statement, what will happen is if I run select star on employees, this 2 also has been updated, right? That's the idea of on cascade update, right? If the parent column value is updated, the child row value or the child value or the child column value will also be updated accordingly, right? In the same line, on cascade update, on cascade delete, we have another functionality called on delete set null. That means if you try to delete the parent, the child row will not be deleted, rather it will be set to null, right? Right, so we'll take a example of that one, right? So I'll delete my table. So for tutorial purpose, I'm doing always delete and creating the new table, right? In real world, you don't drop table like this, okay? For that, we use alter statement, right? For ease and for convenience and for better example, so that I'll be able to give better example, I'm doing the drop and creating the table again and again, right? So same department table, right? I will execute employees table here. Foreign key that we have already seen, department ID references departments, department ID. Here what I'm saying, on delete set null, right? I'm not saying cascade delete. What I'm saying is on delete set null, right? So I will execute this one. This is created, right? Now I'll create the one single column in department table and two column in employees table, and they refer to this department ID one from here, right? Right, now what I will do is select star from employees, right? I'll run this one. So if you see a department ID is 1 and 1, right? Now what I will do, I'll delete this one, right? Delete from departments where department ID equals to 1, right? I will delete this one. This is deleted. Now what would happen to the employees table? Here I am saying set it to null. So it will set it to null. Earlier, if it was on cascade delete, it would have deleted the employees row. But instead of that, now it has set it to null, right? Now, can we add multiple conditions? Of course, we can add multiple condition, right? So what happens when we delete and what happens when we do update, right? So if you see here, this is the same foreign key reference, right? Referenced to departments, department ID, right? And on delete cascade as well as on update cascade. That means if you delete it, the row will be deleted. Also, if you update it, the child row will also be updated, right? So here I am using both the condition. That's how you can use both conditions, right?